getting back to basic amplification, one thing that I forgot to mention with all these models, we would like to have trans resistance, trans conductance, or a current amplifier. We would like to transfer it into just this. We want to turn it into AV0. And funny enough, it's not that difficult. If you have a current amplifier, all you have to do is multiply it by the output resistance over the input resistance, and you can put it into this model. Output resistance and input resistance stay the same. Okay. If we can also do something, if we have a transconductance, all we have to do is multiply it by R out. Remember, this has units of 1 over ohms. We multiply by the output resistance, and it just goes straight into this model. It's so nice. AV0, we can also just do this, or R in for a trans resistance amplifier, and we get this same. So let me see, R over the R input resistance. And so if we have an amplifier in any other situation, that's what we'll end up with. And so this will help us understand what we want to do is translate it. So we end up with, this is a really common, watch the arrow direction on this. This is really common. There's some weird, this is called VBE, plus to minus is the voltage there. We're going to call that R pi, for whatever reason. Base, collector, emitter. And then there's also, this is what I'm going to call little RO. Okay? And what we're going to do is we're going to connect this up to something. This is a BJT, bipolar junction transistor, I have introduced you to. Okay? Maybe at one point in time, maybe not. But this is the basic model that we have for the 3 legs. If I haven't introduced you to it, what we do is we take a 3-part piece of silicon, N, P, and N. We dope these respectively, an emitter, collector, and a base. Okay? And we make these, and this is going to be the basic, amplification model for it, as far as small signal. So this is all small signal that we have here. And so what we're going to do is we're going to connect this to ground. Okay? What happens is as we push more current in through the base, more current is going to be shoved in through this way. This is called, I'm going to start all the way over. Notice the current arrow goes the opposite way. We're going to ground this. I'm going to give myself a little bit more space here. This is called GM. It's a transconductance gain. Okay, times VBE. This here is VBE, small signal, so we've subtracted off all the DCs to get here. This is R out. That connects out to something. In this particular case, we're going to connect it up to a load. Okay, this is connected to another little signal. Okay, and this is VS, this is RS, this is called R pi, that's a lowercase r, R pi, and so if we have enough information about this, we could figure out how this turns into, anyways, so this is the model for it. What they're going to go through and do is they're going to give us different values for this particular problem. And so, for example, GM is equal to 40 milliamps per volt. Okay, so they've just told us that that's what that's set to. R out is equal to 100K ohms. Okay, RL is 5 kilo ohms. Okay, RS is equal to 5K. R pi, sorry, that was lowercase, is equal to 2.5K. Okay, and let me see, I think that's all we know. And so what they want to know with the first one is if we neglect this guy, what would be the gain value for that? In other words, the voltage gain. Okay, we want V out over the effective. Okay, they want to know V out over Vs. This is the effective gain value. Okay, and so the question is, so this is going to be pretty straightforward for this, but that's going to be the question, is what we're going to get for this. And so what we have to look at is we have a voltage that's going to be applied here, and it's going to create a voltage over these guys. So we're going to neglect this. We're just going to have the RL. And so the voltage gain, so V out, what's V out going to be? Is going to be RL times, so if I do it here, times negative GM times VBE. Okay? VBE is equal to Vs times R pi over R pi plus Rs. Okay, and then when we get in here, we're going to get an S up here, we're going to divide it out, and that's going to give us our effective gain values. I threw the negative sign in here because the current's going this direction. So let's go to MATLAB and throw in some values. Okay, and so we're going to throw in GM is equal to 40 e to the minus 3. Okay, we have RO is equal to 100 e to the third. We're not going to use that. RL is equal to 5 e to the 3. We don't use that one either. RS is equal to 5 e to the 3. R pi is equal to 2.5 e to the 3. And that should give us enough of equation over here. What we're going to get for the final on this is that V out over Vs, and I know this is getting rather small here, is equal to RL negative GM times R pi over R pi plus Rs. So that's what it should be for all of this to get the final gain. We're going to crank all those in there just exactly like I have it there, which is going to be RL. So I guess RL does come up. I was wrong about that. Times negative GM times R pi over R pi plus Rs. And we end up with negative 66.6 volts per volt. Okay? And so that's what this is going to turn out to be, negative 66.6 volts per volt. That's actually a good result. That's a lot of voltage gain. It may not seem like a lot, but that actually is a lot of voltage gain for a single stage. The next question they have is we want to use a different amplifier, and I think we're going to leave that one off for right now. But that's the basic idea. Now, here's a question. We had to go and do a little bit of electronics with this over here. Let's translate that. Okay? Because if we don't neglect RO, that becomes really complicated. Let's translate this now into, and given it's going to be like that, R out, this is going to be little r, O. If we can translate it this way, this is just going to be minus GM times, and what was this, times RO. Should do this, and we should get the same kind of voltage gain from that. Okay? In other words, this is a lot easier to deal with. We understand the voltage divider over here. Life is really well, and so let's just calculate that really quickly. And what we end up with is negative GM times RO is equal to minus 4,000. Of course, they were saying that that was infinite. okay, or that was an infinite resistor. It was so big that RL didn't even touch it. So we're not going to go into that too much, but that's the way we translate this into a voltage gain circuit rather than a current gain circuit. So I think that's a really good example of what we would use for, why we'd want to transfer a current source into a voltage source.